Hey everyone, today what we're going to be doing is, this is probably my favorite lab that we do in the lab. I wish I could be performing this one with you. We're going to be looking at comparing family behavior. Now just going to a periodic table here. I talked about in a previous video that, so we have our staircase right here, goes right down through there, and we know that everything over here on the left side of the staircase is a metal, except for this guy. And everything on the right side of the staircase is a non-metal. And the reason that hydrogen is over here, even though it's not a metal, is that even though it doesn't look like its family, it doesn't look like an alkali metal, it reacts like one. We discussed in our family of behavior, or family behavior of metals, that the alkalis here are the most reactive of the metals. They react very, very fast. Our alkaline earth metals here are second. And so reactivity is the most here, and it decreases as you move inwards. I also told you that as you move down the family on the metal side, things become more reactive. So what I've told you is that lithium is very reactive. Sodium, even more. Potassium, even more. Rubidium, even more. Cesium, even more. And francium, even more. Now, moving in the table, sodium is the most reactive here. Magnesium is reactive, but not as much. Likewise, potassium is very reactive. Calcium, not as reactive. But moving down, calcium is more reactive than magnesium. So what this lab is designed to do is it's designed to show you that, and you're going to be looking for this. Now, it's a little bit easier to do in the laboratory because you use the same amount of water and the same amount of metal each time. So we have a constant. I found some videos for you. The problem is from video to video, they're using different amounts of water and different amounts of metal. So, for example, if you use sodium is more reactive than lithium. But if you put in a little bit of sodium and a whole lot of lithium, it's going to make lithium look more reactive because there's so much more of it. But if you put the same amount of each metal in the same amount of water, sodium is definitely more reactive. So I'm going to have you look at the videos. Some of them are good. Some of them show you the reaction, but it's way more reaction than you should actually see. And I'll actually get to the aluminum one. I believe it was the aluminum one, or maybe when we get there, I'll find out. I'll let you know. But one of them, I'm not even going to have you look at the video of, or if you do look at the video, it doesn't represent what we're trying to do here, and it skews that result. So please note, more reactive as you move down the family, and less reactive as you move across the row. All right, so back to our lab here. Now, these are basically what you're going to do. You're going to take these metals and you're going to react them with either water or hydrochloric acid. Now, in class, I would do lithium, sodium, and potassium for you. And like in the video, you'll notice that when I cut lithium, sodium, and potassium, I would cut them with a butter knife. They are kept in oil. And the reason is they react very quickly with the oxygen in the air. So if we just had them in a container, they would react very quickly, and you'll actually in the video see this reaction. So they're kept in oil. I would take them out of the oil. I would rub off as much of the oil as I could, and for all three of these, they would look either white or black. So there's a tarnish on them, and that's a new substance that has been created when the metal and the oxygen in the air has reacted. I would, with my butter knife, cut them in half, and you would see in all three of these cases they're very shiny and silver on the inside. And literally right before your eyes, you would watch the reaction take place with the oxygen in the air, and they would tarnish over within seconds in front of you. Lithium might take 5-6 seconds before you don't see this shiny silver anymore. Potassium almost instantaneously. So very, very fast. So you'll see those in the video. I'm also going to show you the video of, or I've included a video of magnesium and water. Now, magnesium is an alkaline earth metal. It's one more column in. So it's not as reactive as these. If it looks more reactive, that's only because more water and more metal, but it's not. But I've provided for you the video so you can see what the reaction looks like. It would just be much, much less. Aluminum and water, you can do this one on your own. Take a piece of aluminum foil and put it into some water. I think I've included the calcium and water. Once again, calcium should be more reactive than magnesium. It's further down the family, but it's going to be less reactive than its alkali metals. So in the video, if it appears more reactive, that's only because it's a bigger chunk. But what you would be seeing in the lab is the same reaction, only much, much less. So in the video, if there's a ton of bubbles, with the amounts that you would be using in the lab, there'd only be a little bit of bubbles. And I can't remember. I don't think I show you aluminum and hydrochloric acid, only because I couldn't find a good video of it. All the videos show a lot of hydrochloric acid and a lot of aluminum, and so you would not see that reaction inside the lab. With the aluminum and hydrochloric acid, you see some very light, gentle bubbling. But I'm only giving you a small amount of aluminum, like a little piece, I don't know, half a centimeter by half a centimeter, and 3 or 4 drops of hydrochloric acid. So you do see some really light bubbling, and that's it with those amounts. If you were doing this lab, basically I would give you a spot plate. It's a plastic plate with a whole bunch of little holes and a whole bunch of little dimples in it where you can mix these things. And so you would put a little piece of magnesium, once again 2 or 3 millimeters by 4 or 5 millimeters long, just a little piece off of the magnesium tape. You would put in 5-10 drops of water, and you would watch for a reaction. Likewise with calcium, the piece I give you, I'm trying to think of how big that piece would be. Think of a little round piece of calcium and a little round ball, and it would probably in diameter only be 2-3 millimeters. So just little tiny pieces. So give this lab a try. Of course, for your observation of reaction, if the reaction in the video looks more than it should be, just talk about what you're seeing. I'm seeing bubbling. And just know that the bubbles, what you're seeing is probably way more bubbles than you would have seen in the lab. But your observation still should be correct. The lithium, sodium, and potassium that you see in the video is good. I think I'll also include a link to another video that shows the next 3, the francium, the cesium, and the rubidium. That's the wrong order. Of the alkali metals, just so you can see how they get more reactive, but of course they're not part of this lab. And then you will work on these questions, and that is that. If you have any questions, please don't hesitate to contact me. I can send you off a video. I can write something up for you, email you back. I get back to you all times of day and night. And so that's that. Good luck with this, and hope to see you all soon.